Hi, welcome to your lesson on measures of central tendency. Okay, here is the question that we want to answer when we talk about measures of central tendency. When we are faced with lots of numbers, how do you know which average, and notice that's average in quotations, is best to use? Because when we hear the word average, we often think mean. However, in here, we're referring to average in a general sense. Let's say you have a bunch of data and you want to say, hey, what's the kind of average of that data? So there's different ways to look at that. Basically, what we're looking for, though, is a measure of central tendency, which is some measure that tells us where the middle of a data set lies, right? When we think about the average, we think about what's kind of the middle or what's the middle value? So that's what measures of central tendency give us. There are three most common measures of central tendency, and they are the mean, the median, and the mode. So imagine you had data that's spread out like this. So you have some data here, a little bit more, and most of the data is in the middle, less, 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 less. In that kind of data set that's symmetrically distributed, the mean, the median, and the mode are all the same value. It's like that most occurring value in the middle here. However, let's say more typically, we have data that's spread out in different ways. For example, this data shows a skew to the right here, a positive skew. In this case, the mode will be here, the median will be somewhere here, and the mean will be even further this way. Basically, what this shows us is the mean is more influenced by values that are outliers, that are different from the norm or different from the majority of values. So we'll take a look at that in more detail as we go here. Okay, so let's define those more clearly. So the measures of central tendency, again, they tell us where the middle of a set of data are, and here's our most common ones. So measures of central tendency, or averages. The most common measures are mean, median, mode. To begin, mode. A mode of a data set is the value that occurs most frequently. There may be no mode or several modes. Okay, so unlike median and mean, there can be several modes. Okay, the median of a data set is the value that lies in the middle when the data is arranged in size. It's the middle value. When there are two middle values, the median is the midpoint between these two. We'll look at these calculations in just a sec. And the last one is the mean of a data set. It is the sum of all the values divided by the number of values. I think you're familiar with these three, but we're going to look at them through an example here. So first of all, let's say we have this data set here, a small data set, 6 pieces of data, and we are looking for the mean. The mean is all the numbers added and then divided by the amount of numbers. So the kind of general formula for mean looks like this. First of all, we can use Greek letter mu for population mean, or something called x bar to represent the mean of a sample. And the mean formula in general is this. Here we have a sigma symbol, means the sum. So the sum of all the x things from 1 to n, that means your first piece of data, second, third, fourth, and so on. So you're summing all the data points or all the data values, and then you're dividing by the number of data values. That's all that this formula means. And we know how mean is calculated. So here we're going to apply it. See, to find the mean, or x bar, we add all the data values here, and we divide by 6, because there's 6 of them. That gives you the mean, and the mean in this case is 5. Okay, the next way we can represent or talk about the center of a data set is the median. The median is found this way. We order the set of numbers, and the median is the middle number. For example, we take that same data set, we reorder it from lowest to highest, and now we're looking for the middle value. One thing when we find the median, you should know this little formula here. This formula is used to figure out the position of the median in the data set. We do the number of data points plus 1 divided by 2. So for example, here we have 6 data points, so we do 6 data points plus 1 divided by 2. That gives us 7 over 2, which is 3.5. That tells us not what the median is, but the position of the median. So this tells us in the data set, the median is at the 3.5 position. So here is position 1, 2, 3, and then 0.5. It tells us the median lies between this data point and this data point. And that makes sense, because if we put the median right in the middle here, so check it out, right there. We say the median is right there. Here's 3 below, 3 above, so the median will be right in between there. And what's the number right in between 3 and 6? Well, we can find that by taking a little average. 3 plus 6 divided by 2, 4.5. So that's our median value right here. So again, n plus 1 over 2 gives us the position, and then once we know the position, if it falls between two numbers, we can find it by just averaging the two numbers on either side. Okay, let's go to mode. Mode is the third major way of looking at the center of a data set, and it is the most common number. For example, in our data set, the most common number is 3. It occurs twice, so that's our mode. So now look at the mean, median, and mode. For this single data set, they are very different, but they're each used to represent when somebody asks the question, what's the average, or what's the what's the average value expected in this data set? And they all tell a different story. Okay, so let's take a look at this once more. Here's a normally distributed set of data. It is symmetrical. We can see most of the data is in the middle, and then less to the low side and less to the high side. Since it's symmetrical, the mean, median, and mode will all be at the exact same value. Now, when the data is skewed like this, all right, then we know that mean, median, mode will change. The mode will still be here, because remember, mode represents the most frequently occurring data value, and we can see if this was a histogram, this would show the highest frequency. We'd have the most data right there, and therefore that's the mode. The median is the middle value, and since there's more data points down here than there is on this end, then the median value must be to the left of the mode, because it's the middle data point, which will be somewhere in here. The mean is affected by these values here. If you had very low values and then you add them all up and take the average, these low values will pull the average down, and that's what this is showing. The mean is here, affected most by these outliers. Same thing we see here when we have a skew in the other direction. Again, the mean is pulled towards that end because these high values influence the mean. Mode is here, most frequently occurring, median is here. All right, that's how these things work in general. So here's an example of that. We're going to see how mean, median, and mode are affected when we have an outlier. So the data we have here is 12 adults, and we've measured how many times they smile per day. Okay, look, some adult here smiles only 3 times, another one smiles 15 times, and then all the other adults smile some number of times in between 3 and 15. Okay, interesting spread to that data. If we find the mode of that data, it's 11. We can see 11 occurs most frequently. So if somebody said, what's the middle, what's the average outcome, you could say, oh, it's like 11, all right, because it occurs most frequently. Or you could say, well, I'm going to calculate the mean. You add all these up, we get a mean of 8.9. Notice the mean here is much lower than the mode because we have all these low values here that pull the mean value down. Okay, finally the median. We're going to find the position. Median position is found by doing n plus 1 over 2. So here there is 12 data points, so we do plus 1, 13 over 2, 6.5. So at position 6.5, which is right here, 1, 2, 3, 4, 5, 6, 6.5, between these two numbers we have the median value. And the number between 8 and 10 is 9. But again, to calculate that number, we can do 8 plus 10 divided by 2. We're finding the average between those two, and it's 9. Okay, great. Notice we get a different story from each one. Mean and median are close. Mode is higher. Which one's the best one that tells us about what's really happening in terms of this data and where the middle is? We don't know. It's kind of a subjective thing. Now, let's say we include a child in this data set. And this child, look at this. Whoa, right here. We know that children are happy. They don't have all the worries of adults. So this child smiles 52 times per day, way higher than all these adults. So look at that. Now this is an outlier in this data set. Let's see how it affects the mode, mean, and median. So the mode is still 11. That's still the most frequently occurring. So that outlier didn't affect it very much. The mode remains what it is. If somebody said, what's the middle of this data? You'd say it's 11. That occurs most often. Okay, next, the mean. Notice how the mean has gone up. It went up significantly from 8.9 to 12.2. That single value just pulls the mean up. And finally, the median. The median is now we have 13 data points. We add 1, 14 divided by 2 is 7. The median will occur at position 7, which is right here. So now it is one of the points in the data set. It's not a half position like this. It is one of the points in the data set. So the median is 10. So the median went up slightly. The mean went up a lot. The mode stayed the same. So again, notice when we have outliers, like here, we have outliers here and here, the mean is affected the most. All right, good. Let's take a look at this. Same situation, I mean, same kind of thing we're going to look at here. We have a salary, monthly salaries in Australian dollars of 12 employees in a factory. I'm going to arrange those in order. Here's the salaries. When we arrange them in order, we can clearly see these two outliers here. So the mean, sorry, mode 4,400, we can see it here. The mean 8,458 if we average all those. And finally the median, find the position, 14 divided by 2, position 7. This is position 7. That is our median, 4,400. Notice the mode and the median match. The mean is much higher because of these outliers. So you have to decide, is this number really tell you the true story of the average salary? If you looked at all these salaries and somebody said, hey, what do people make in general in this factory? Would you say this number? No, I think you'd say something more like this. So in this case, the mean doesn't really tell the accurate story because most people are making this low number in the 4,000s. And just because there's two people, maybe these are the managers, they make a lot more, doesn't mean that this mean is really a true part of this story. It doesn't really tell the true story of most of the people in here. So I'd say using mode and median here is better. Okay, next, we have this ages of students in a chemistry course at university. All kinds of ages, they're out of order here. I've reordered them here. And again, we have all these like typical college age, university age students here. And then we have these two seniors kind of in this course. And that happens often. Old people, these are not old people. They're almost my age, or I'm almost that age. But anyway, people when they retire, maybe they have some time on their hands and they decide to go back to university and learn some things. So we have two people that are older sitting in on this course. Okay, what's the mean? Okay, sorry, first mode 19. We can see lots of people age 19. So we can say, hey, the typical person in this class, 19 years old, great. Next, mean 23.8. Again, that tells us a very different story. Is that really the true typical person in this class? Not really. Most people are 17, 18, 19, and so on. This only is as high as it is because of those two people, right? So again, these two outliers really affected that. And the mean doesn't really tell the story of who's in this class. If you said, hey, in general, people are 23.8 years old, that's not really true. Most people are not that old at all. Okay, next, median, n plus 1 divided by 2. 19 divided by 2 tells us the position, which is 9.5. I go to position 9.5. It's right here between 9 and 10. And in between those numbers is 19.5. So that's the median. So I think the median and the mode tell a much better story about the center of this data. Okay, let's keep going. Find the mode of this data. That should be easy. Great, the mode is 7. Easy, most occurring value. Next, a group of students were surveyed, and we were looking for how many hats they owned. So 3 students, this is a frequency table. 3 students have 0 hats. 7 students have 1 hat. 3 students have 2 hats, and so on. What's the modal number of hats? What's the most frequently occurring number of hats? And for to answer this one, I would say, first think about if you wrote this list of data points all in order, what would it look like? You would have 0 3 times, then you would have 1 7 times, and so on and so on. So which one is our mode? Well, in this case, our mode is 1 hat, because 1 hat is the most frequently occurring piece of our data set. Again, if you wrote all those data points out, you would have written 1 hat 7 times, so that's the most frequently occurring one. Okay, hint, there are errors that students commonly make here. One error is that students would say the mode is 7. They just look at this part of the table and they say, hey, that's the biggest number. But remember, that's not our data. This is our data. And this is just telling us how many times each of our pieces of data occurs. Error number 2 that commonly happens. Students would answer, the mode is 3. Why 3? Oh, they look at this one here, and they're like, oh no, sorry, they see 3 appearing twice here, or 3 times. And they're like, that's the mode. Again, this is not our data. This is our data. And this is just the number of times each of these data points occurs. So this is our data. Focus on that, not the frequency numbers on this. All right, great. Here's another one. This shows the ages of students who exercise in the gym after school. Find the modal age. Which age would be our mode? Which age occurs most frequently, right? Here's the frequency. Which one occurs most frequently? All right, clearly here we are talking about something different. Here's a range of ages, right? We don't know what age 16 or 17 occurs most frequently, but we know that these ages occur most frequently between 16 and 17. So we call that the modal class. And in this case, the modal class is ages 16 to 17. Alrighty, let's keep it going. Here's the next one. Now we're going to talk about the mean. So what is the mean number of chickens in this set here? Okay, mean, again, just to recap, is the one that is most commonly called the average. And we can find it by doing the sum of all the data values divided by the number of data values. Here's sum of data values divided by the number. In this case, it works out to 400 chickens. Next, here is a frequency table again, and it shows IB grades earned and the frequency of students earning those grades in some course. Find the mean IB grade. This one is a little bit different, right? When we have a frequency table, the mean is a little different. We can see 7 occurs twice, 6 occurs 4 times, 5 occurs 8 times. So again, this one is helpful to think about. What would it look like if I wrote out this data set in full? So if 7 occurs twice, I write 7 twice. 6 occurs 4 times, I write 4 sixes, and so on and so on. That's what my data set would look like. So if you're finding the mean, you want to add all those up and divide by the number you have. How can we shortcut that whole thing, right? We can do 7 times 2, and that gives us 14. And we can do 6 times 4, which gives us 24. Because, again, 7 times 2 is the sum of these two. And 6 times 4 is the sum of these. And 5 times 8 is the sum of all those 5s. So these are the sum of all those values. We need to find the sum. Then we find the total sum and divide by the number of values. The number of values we have is the sum of the frequencies. So the frequencies add up to a sum of 20. So therefore our mean is the sum of all these, which are the result of multiplying these, 98 over 20, which is the sum of these. Think about that for a moment. It's not a difficult concept, but pause for a second and just think about what happened here when we're finding the mean. You need to know how to find the mean from a frequency table. Okay, next. We have this. Okay, so again, we have a frequency table, but this time there's classes that have ranges here. It shows the ages and years of 10 pets. So 2 pets are between 0 and 2 years old, 4 pets are between 2 and 4, and so on. It says estimate the mean age. So just like we did in the last question when we had a frequency table, you're going to multiply the value by the frequency to find the sum of values. However, in this case, we don't have an exact value here. So what are you going to do? How are you going to figure out what value to use here? And that's why it says estimate here, because we don't know if these 2 pets are 0 years old or 1 year old or 2 years old. They can be anything, right? So if we don't know the actual ages here of these 2, then what can we use to figure it out? The answer to that is we take what's called the mid-interval value. So what's the middle number between 0 and 1? It is, sorry, between 0 and 2. It's 1. What's the middle number between 2 and 4? 3. So we're going to use the mid-interval value and multiply that by the frequency, because we're essentially saying, okay, there's 4 pets that are between 2 and 4 years old. And we're just going to assume, since we don't know what their ages are, they can be anywhere between 2 and 4, we're going to assume that on average they're all about 3 years old, and therefore we're going to do 3 years times 4 to get 3 of those pets, sorry, 4 pets, 3 years old, total of 12. And we can see these totals here. Okay, 4 times 3, 12. And then you add those up like we did before, you get your total for all those ages, and then you see what your total for frequencies is, because that tells you how many data points you have, and you divide those two, 36 divided by 10. Again, pause for a moment, make sure you understand the process here. Not difficult, but important you know how to run that process. Okay, next, we've talked about mode and mean, and now we're going to look at one more mean question. This is a typical kind of mean question. You have 4 scores earned by a student on mathematics tests, and find the score Will must get on the last test to finish with an average of 90. So consider the last test being a score of X, some unknown value, and then just set up an average formula. Try it now. So here's how you do this. Here's the 4 scores he has. Here's the unknown last test. Divided by 5. He needs an average of 90. Solve for X. Check the work there. We're solving for X. We're solving backwards. All right, next one here. Now we're talking about median. Remember, median means the middle value. Look at those. We're going to reorder them. The median, again, is the middle value when you reorder numbers. The median was developed in the 19th century by German psychologist Gustav Fechner. Okay, all right. And then later used by Pierre Laplace and of course many others. So here's the reordered list of numbers, and when we reorder it, we can use that median position formula we talked about earlier. Number of data values plus 1 divided by 2, 6. So we know at position 6, which is this one, is our median, and in this case it's 10. Great, next one, find the median here. This data is already in order, so we're going to find the median position. Number of data points is 8, plus 1 is 9, 9 divided by 2, 4.5. So the 4.5th data value, which is in between the 4th and the 5th, is right here. What is that? What would be that middle number between those two? Again, when we have numbers like this, sometimes it's obvious what the middle number is between them, but other times we need to actually find the average to find the middle. So 39.5 plus 41.3 divided by 2 gives us the average. And that's going to tell us the number right in between those two, and that number is 40.4. Great. One last one. We have a table here, represents number of pets for a group of 25 children. So 4 children have 0 pets, 3 have 1, and so on and so on. It's a frequency table again. Find the value of Q to begin. Okay, Q is found by adding these up, and they must be 25. Because we know that there's 25 children, so these frequency has to add up to 25, so we can find Q. All right, and then we're going to use a median formula to figure out the median number of pets. So here's that Q value of 5. And now the median, well, the median is going to be the middle value. So if we know there's 25 data points, we're going to put 25 plus 1 divided by 2, which tells us the median value is the 13th position. And when you look at this list, in the 13th position, well, there's 4 here, 3 more here, so now we're at position 7, 8 more here, now we're at position 15 if we get to the end here. So if the middle value is at position 13, it must be a 2, because this takes us already to position 15. Awesome, great work. You can do it. There's one more video to watch. You can do this. Let's do it.